there's a word that I would have never, I don't even, not just data centers, probably until 4 years ago, 3 years ago, I would have never said this word, and it's densification. Like I sometimes just walk around and say densification. Like it's worked its way into my lexicon. And usually when we talk about that, we are talking about it again from a power or cooling. When you hear the word densification, for people that are near our industry, from a connectivity perspective, what does it mean, and why are we talking about it?
That's a great question. So, and like you, densification was not part of my vocabulary just a few years ago, but from my perspective, it really translates to fiber strands, right? So we have relied on fiber optics to transmit data for decades now to power the internet. But with the AI revolution, we're seeing that amount of fiber that it takes to reliably transmit the sheer amount of data between compute nodes, GPU nodes, and having that available in real time. It takes a lot of fiber. It takes a lot of lanes. So just I tend to kind of equate this to the superhighway analogy. So back in the day, we just had two-way streets, right? There was no congestion. But with the added amount of data, we've added so many cars onto the roads. We've had nothing but congestion. But in order for AI to be effective, we can't have congestion. We've got to be sure all lanes are clear. So we're having to incrementally add lanes, and that. So we've got a sheer number of fiber strands that are now being added. So think about comparing a traditional data center to an AI data centers. Any experts think about four times to 10 times more fiber needed to facilitate all of the data transfer between nodes and between data centers. So that's a lot of fiber. We're obviously trying to build bigger buildings, but the building size is typically defined by the number of racks. Certainly now we have power and cooling infrastructure to worry about, but really the physical space to place all of that additional fiber into a rack has not increased substantially. So we're now talking about individual fiber strands just multiplying significantly. We still have the same rack dimensions. We need to fit all of that additional fiber and the connectors into a much smaller footprint than we've ever had before. So that's what we talk about when we say the term densification in the network infrastructure space.
One of the things that I didn't appreciate until recently, there's this idea. So once upon a time, a typical compute rack in a data center. So the rack is where all the servers live. On the back of the rack is where we connect the fiber or the copper, whatever it is. On the front of the rack is where humans interact to plug their keyboard in, or the cold air would come draw through so it could cool the infrastructure. It's pretty orderly flow of how people interact and the environment interacts with these computer systems. The back end would look really busy. Hopefully it had a great, mature, structured cable program so that it was tidy, but it was busy. There was a lot going on back there. And the front tended to be cleaner because that's where people were touching. And you didn't want confusion and you didn't want mistakes. And as we've thought about these racks going from about 5 kW, 3 or 5 kW, so that's the amount of heat they would draw. And so that could be 10, 15, 20 slender computers in a row running at a modest performance rate. But to the point of our discussion today, the modern, highly utilized, usually with GPUs, not CPUs, these racks are going to run much more powerfully. It's not your little local four-door sedan driven 6 minutes to school. It is freight trains full speed, full loads, doing their job, which is what we want. That's where you get the most efficiency, you get the most value. We want to pack them full of stuff. But when we do that, or the comment was, well, now these racks, you're not going to need as much space. So where you would put 10 racks before for 50 kW, so 5 times 10, well, now you're going to have a one rack at 100, 200, 600, whatever the number is, but you're going to shrink it all the way down to this one rack. And what we're learning to appreciate is, sure, so all that compute is right there, but now here's where it's changing. You just said it. In order for those workloads to work well, they have to connect to the things within the rack, and they have to connect to things adjacent to the rack without obstruction. And so they're moving really fast. They're moving really big loads. And so now I've got to fit them in. I've got to fit that into this space. And so where we thought maybe we were going to gain a whole bunch of space, maybe we're not, because now I've got to put this connectivity infrastructure in, and I've got to have room for the humans to install it, uninstall it when it's time to upgrade it, service it, etc. Oh, and I have to cool it too. And we had been looking at removing, there's a lot of conversation for years about slowly removing UPS infrastructure from these environments, with maybe the exception of the network core, because they don't fail elegantly, but certainly the computers. And now we're rethinking, well, hold on. This one rack is really expensive. That network, that InfiniBand or other components that are in there is expensive and complicated. I need to put all of that back on UPS. So I guess my point is, when we're talking about densification, there's a lot going on. And one of the things that you talk about is, look, we all have to innovate. We're innovating in the compute side. They're innovating in the cooling side. But your team and people like you have to innovate in this connectivity piece, not just to meet the workload, but to fit into the environment.
Absolutely right. And that's where, we continue to focus on miniaturizing the infrastructure, right? So all we're left with is we don't have the luxury to ask for more space, right? So we have to think about and innovate. How do we make things smaller? Ultra high density fiber cables, for example, we're continuing to work on how do we reduce the fiber diameter? How do we squeeze more fiber strands into a single cable to maintain and reduce the footprint of the cabling itself? From a connector innovation standpoint, where we're now, we're able to squeeze 16, 24, even 32 fibers into a very small connector that used to be a footprint for just 2 fiber connections. So, and then the panels, of course, they're getting denser as well. So that's really where the innovation happens in our industry. And as you can imagine, folks that actually have to work on this stuff once it's installed, it's very small, right? So. Yeah. If you've ever worked on something and you have big hands and you can't even get your fingers into to remove a connector just because everything's so tightly packed, that's a problem. So we also have to overcome the challenge of how do we keep it serviceable, right? How do we ensure that people can work on it once it's
installed? Yeah, it's funny as you're talking, I started laughing. I wasn't laughing at you. I'm just imagining I have big hands, and I've been married almost 40 years, and I can't even get my little buttons on my collar buttoned. I have to go to my wife. I can't get anything that's finesse. And it's not, I don't know if it's so much the size of of hands. She has smaller hands than me, but she is just skilled and she's what I would call nimble. She's very, very skilled she's an artist. She's really good at little small things like that, threading a needle, whatever. I could barely sweep the floor. I can do a lot of things, but I can manipulate large objects. She can manipulate small objects. And I'm just imagining not just the tightness of the space, but the complexity of managing all that cable infrastructure I mean, there's got to be a role for AI to help your technicians keep track of what's going on, or at least be developed to help look over their shoulder. Here's what's going on. Here's the labeling format. I'm imagining the densification of this space, and it's got to be intimidating. I don't know. Do you guys have an innovation lab? How do you spend time in developing the products and services there?
Yeah, certainly innovation labs, R&D, where we're consistently working to, with our bright engineers and researchers of how do we make this stuff smaller? Are there innovative ways to continue to ensure performance in getting this stuff smaller? But you mentioned using AI tools. I mean, there's a software plays a big role in fiber or structured cabling infrastructure now, and it has for some years, but it's really coming into focus now where with the potential that AI has, it can help us kind of keep track and at least design and plan the space. And that's kind of to circle back to our initial opening discussion. That's what makes it so important to be part of the discussion early. Some of these innovations are only effective if we can be part of that design process of upfront, right? It has to be a consideration that takes place, not at the back end when you're ready to put the infrastructure into the racks. So, but AI can do some wondrous things, as you kind of talked about, managing that density, thousands of fiber connections in a single rack. I mean, you've got to have some way other than just a spreadsheet in Excel to keep track of all of the cables. You want to also make sure that for day two activities, if you do have to move connections, that there's an automated way to keep track of that. So there's a lot of innovation that's happening in the space. I'm really, really excited about some things that to come. But ultimately, we can't continue to do this the manual way as we've done so long.
Yeah, we're going through a revolution ourselves as our technicians are out on the floor, whether they're racking and stacking infrastructure or they're just walking through the hall, experimenting with tools that are listening to the harmonics of the fans as they walk by. Before any tool says anything, is it hearing a dissonance? It may not be wrong, but is there an anomaly that it's hearing from the infrastructure? Or as I'm doing my normal checklist or maintenance, and if I have an AI assistant, what we dig is it doesn't replace people, it just enhances people. It's like you have your own personal Jarvis there. Maybe someday when I'm a technician working in a structured cable plant and I have something looking over my shoulder, my helmet with my body cam or whatever, and it's able to see, oh, hold on, you might not notice this, and the tool hasn't brought it to your attention yet. But this thing isn't, it's showing you the send receive lights or whatever, but it's not quite firmly. Just double check that. When you're talking about a densification of environment and there are a number of things going on, I want both the human intuition experience and to have robots and things get in there. We talk to a lot of robot people. That's so far away, this nimble, agile, whatever. They do a lot of things. There's incredible things they can do. But what we're talking about getting in and around it's probably not imminent. But these tools, this interactive tool as they're being developed with HD cameras and other sensors partnered with the human now becomes a cyborg. Right. And it's spectacular for both of them, and it leads to much more accuracy and efficiency. At least in our experiment, that's what it appears anyway. Is that your experience?
Yeah, absolutely. I mean, there's significant potential just with AR, VR tools, for example. You look at just any fiber splice, right? There's a lot of considerations, and then ultimately a quality check. It has to look at every splice, a splice case, certainly from a connection or either a fiber connector end face cleanliness. All of these things can now be automated, right? Where you don't spend weeks on a new greenfield build during commissioning, validating all of that. That can now be done just with some of the amazing tools that are available and coming out on the market. So I'm really, really excited. There are also a number of tools that help. And I don't know, Dave, if you've ever been on just a massive data center campus construction site.
Oh
As
yeah.
you can imagine, there's a lot of activities, and
Yeah.
it's becoming increasingly more difficult just to have bodies on site because they get in each other's ways. So, having these planned out mechanisms or tools that kind of tell you what to deploy where you're not having to go through large inventory of fiber cables. And these days, a lot of the fiber trunks that come to the site, there are specific lengths. They go to a specific rack, right? For someone to have to sort through that and figure that out on site, it's just a lot of wasted time. So having tools available that tell you exactly this QR code on the cable goes to this rack. We're going to do like these 20 racks today. So you're going to pick all of this infrastructure. So just automating what used to be a very cumbersome job and certainly very error-prone job as well.
You probably wouldn't do this, but I am tempted on occasion when we go in and we sit down in a planning meeting. We want to go, whether it's a data hall or a suite or maybe an entire building. We want to do this, and we see what they want to do or how they are imagining they're going to solve the problem, especially around the topic of densification. And it's not very charitable of me, but sometimes I just want to say, with my most elegant voice, you're an idiot. I don't know what you're trying to do, but there is no way, to your point about logistics, you can just get the many bodies in or cables in or panels in. How do you, in a much more elegant way, come alongside some of these customers, capture their imagination elegantly, evaluate what it is that they want to do, and maybe help adjust a perspective so that you can actually help them solve the problem? In other words, think of a business challenge they're trying to solve and come up with a technical solution for it that's really going to get them where they need to go. Because what I have found is that can be tricky. Some of them are great partners or in an area of uncertainty, but especially in connectivity, because they feel like they've got this. We've done this for a long time. We know how to do it. But to sit down and say, hold on, I don't think you understand the order of magnitude, and we may need to introduce a different way. You were alluding to modularity earlier, and I would love maybe, coming back to that. But the data center industry doesn't like innovation unless it's 10 years old. And so, to bring some of the new ideas, how do you manage that, first of all? And what are some of those things you think are going to help them adjust to the densification challenges they're going to face, whether they know it or not?
Right. I think it circles back to just being part of the conversation early, right? And I think that comes with time. From what we've seen with our customers and partners, once we have a seat at the table, they have seen what our capabilities are, and the conversation is very, very easy, right? Those are open, innovative discussions. We're able to actually be part of the planning process. With others that might not give us a chance, the opportunity is still there when we talk about the schedule, right? The deployment timelines. There are ways to challenge and actually with fact-based and data actually show what's feasible and what's not. And sometimes you're successful in creating that open door to have an educated conversation and potentially persuade to change the plan. Or sometimes, unfortunately, the lessons are what they are. You might have to, unfortunately, go through a not ideal experience, right, for that lesson to be learned. So fortunately, I would say, though, I think that most of the customers that we're working with, that they're very open. I think they understand the importance of the network infrastructure in their builds. But we've also had some experiences where sometimes, unfortunately, the lessons have to be learned the hard way.
Yeah. When are you running for politics? Because that's a great not call out my customer answer. I love that. Unfortunately, sometimes you have to go through the pain of burning yourself because you wouldn't have listened. I'm one of those people, unfortunately, that, the lessons way too often have to be learned through pain, not through I don't know why. It's much less now, much older than I am, but certainly there is a period of time, even in my engineering days, where no, I got this figured out because I test, I've built environments, I'm pretty good at it, at least I would think so. But I didn't, one of the things I had to learn, and it sounds like you're able to do, is you can have a different perspective just because it's the way we did it. Sometimes, yeah, we should continue to do that. There's no reason we should continue to have clean water or whatever it is. Like these things, there's a reason why all societies on earth do a particular behavior or whatever, because it leads to human flourishing. We don't need to change that. But from time to time, as we get new methodologies or new materials or a new way of thinking, we need to at least have the courage to evaluate it. And I know, especially in the engineering world, we can be a little cocky. When I was in the military, we can be a little cocky because look, we got this. We're an expert. And so to be elegant enough to capture their imagination and say, consider this is as big a skill as developing the densification components and the software components, it seems to me.
Yeah, you're absolutely right. And as we find ourselves in such a complex environment, an ever-changing environment, it's prudent that we're humble enough to challenge our own assumptions, right? And
Yeah.
we certainly have to learn that. And I think the our customers who are extremely successful in this space, I think they understand that as well, because the
Yeah.
rules of today aren't going to be the rules of tomorrow.
Yeah. One of the things that I've heard you talk about is modularity. And so many of my guests here recently have talked about modularity, and I love it. But what does it mean in this conversation for connectivity? And why is it that how does it help address the challenges that we're talking about?
Yeah, so modularity in the network sense is essentially two things. You want to make sure that you make it easy for the installer or during the deployment, right? So you want to have, and examples are pre-terminated fiber assemblies. These are typically tested in a clean factory environment and ultimately help to reduce installation time, complexity in the field splicing errors, and ultimately contribute to less waste and faster deployment. But then also modular design, so prefabricated components, anything that you can pre-fit. So high density panels preloaded with cassettes, the pre-terminated cables already attached. It's really simplifying the deployment and thereby reducing risk. But then modularity also helps with density. So when you have, I kind of call it the Lego approach, right? When you kind of swap out cassettes within fiber panels because either the technology changes or you have a retrofit and design change, that allows you to be flexible. The infrastructure that you install today is ultimately with you and flexible enough to accommodate a few iterations down the road. So you don't have to worry about ripping and replacing everything. And that's extremely important as we talk about the density evolution. We're continuing to densify. So, if I'm a provider and I have racks full of fiber panels, the fact that I can potentially swap those cassettes in those fiber panels with higher density, maybe the smaller form factor connector interfaces, that means a lot, right? I don't have to retrofit an entire rack's worth. I can make those changes that I need down the road. So really that well-designed modular system with structured cabling approach really helps to make that network more resilient down the road, easier to manage, certainly faster to deploy, and less error prone due to installers and folks working on the system.
I completely understand the error prone. I have been that installer that I had an amazing fiber diagram. I had all whether it was copper or fiber, pre-labeled correctly. and transposed it or didn't terminate it correctly or something. The temptation, I think, for those of us that have done this for a while is it feels like we're gaining flexibility if I'm doing it on site, or I need to, I run into something unexpected. In other words, if I'm getting it from the factory and it's already, it comes in a kit and the kit just is bolting together. On the one hand, I love the quality control idea of it. I love I don't have to inventory a whole bunch of stuff. And by that, I don't mean spares. I mean, a data hall worth of gear has to sit somewhere before I put it in, and it can't be in the data hall. So it's in somebody's way. But it feels like, so I love all those things where for somebody like me, and maybe you can help us understand in these trade-offs. Let's say, for example, I think today I'm installing the infrastructure and there's a delay and the mechanical guys have to go do something or whatever, some other trade. And so I can't do the thing that I was going to do. So I get delayed, the other groups go do their thing, and then I come back and I do my thing. It feels like, and this probably is a misconception on my part, that if I'm doing it organically on the site, I have more flexibility. Yes, I might have some percentage of inaccuracy, but I'll go through testing, we'll get a commission, it'll be fine. But my advocates, and not just in connectivity, in all these other areas, are like, you're losing too much. What you imagine you're gaining, you're really not gaining, at least not in a way that's valuable. You really do want quality control coming out of the factory. You really do want it to be staged in a particular way. And so our project management team will work with your team to make sure we're real time and able to adjust. But it is to stockpile stuff and to build it and to be able to have what you imagine this flexibility in real time statistically is not just a little, but a lot less efficient, accurate, safe. You want to do it this other way. We promise you it will work out. Do you agree with that sentiment?
Absolutely. So if you've ever been on a project job site and you've taken the flexible approach and you've kind of made do, you splice some things, instead of the pre-terminated trunks that were pre-fitted for one situation, you cut off the connectors and have to splice on additional connectors. Yes, it might seem fast and more efficient in the moment, but at the end of the day, during commission, the time that you think you saved doing that process, you're ultimately going to eat up, if not more, having to clean those connections, troubleshoot, test. In this world, the fiber loss budgets are getting tighter and tighter. It's very hard to get those precise connections doing field terminations in the field. So you spend a lot of time just troubleshooting at the end, and ultimately, I've certainly found myself in a situation where you still didn't meet your construction timeline because of those lingering issues. So and it can also be costly, right? Because sometimes all your efforts troubleshooting or trying to correct an issue, you still might need to place another order with the manufacturer. There's additional cost and additional delay just to get the component or cable trunk to replace whatever didn't quite meet the specs at the end of the day.
I think probably, if I'm honest with myself, as I imagine, so I've been in data centers over 20 years, IT, I don't even want to say how many years, lots and lots and lots of years. And so my company has, 70 plus data centers from 30 megawatts to 1,400 megawatt campuses around the world, either at stabilization or in process or whatever. So I've been around a lot, built out lots of NAS and SAN and network and compute environments personally. I guess what would tighten in my chest is it would require me to, it feels like, is I'd have to have a really good plan. And as I said, I'm really good at the big broad thing. So I have a big plan. Like I know how many U's, I know what or how many U's I need for my compute or what OSs I'm going to do and a patch plan and whatever. But for connect and where, I've got a suite or a cage or a data hall or whatever it is. Like I've got the big pieces. But to especially the pressure in the densification world, I need to be exact. And where I think I'm missing it is in the past, it was just my brain and the 3 or 4, 8 techs sitting around me, the compute guys, the network guys, and the storage guys. And now I have these tools. And they're not displacing the people, but I have these tools. And I have a whole team, but also are using the tools to help me focus in on here's the design, what problem are we trying to solve? Here's the design, and we'll help you build. It will come alongside me as a partner to build an exacting thing. And here's our exception plan. If we run into an exception, there should be just very, very few of them. Here's the exception plan, and we can handle a few exceptions. You got more than a few exceptions, you got a bigger problem. But that's where I get anxious is, that old school kind of, yeah, we got it close enough, let's do it. But in the world that we're talking about now, you just have to be much more take more time planning, I think is your point. Take more time planning, earlier conversations where we're really transparent, and then go build it and deploy it. That's a little bit of time if you spend all your other time getting these things right. Am I on the right track?
You're speaking my language, so
Okay.
I've certainly come with a rigorous project management background, right? And there's always the perception of project management. You've got a plan, you set it and forget it, right? But really, what you mentioned, having exception plans, right? Anticipate changes because they're going to happen, but already think through the steps that you're going to take if X, Y, and Z happens, and then you really don't need to think about when X happens. You just go execute that plan, and it's much better than trying to spin your wheels, trying to solve on the spot, and then ultimately spending more time and money correcting the situation.
Yeah. Well, that's probably why I'm not out on the floor anymore, making sure packets go where they're supposed to do. And I'm having conversations with people that are like, McCall, we love you, but sweet mother of pearl, I don't even know where that stream of data went to. And why'd you open up those 6 ports? Get out of here. Go into a studio. We'll let somebody else do it. Just a few more minutes. I'm really curious. So all of these things that we've got going on, we need people in this world. So how do you imagine we find, like, on the one hand, we're the 3rd most populous country on earth, somewhere between 380 and 400 million. I don't know. We got a lot of people. We attract some of the brightest people on earth, want to come here for a little while or for a long while. But it feels like the skill sets that we need are evolving from the traditional, at least in connectivity. I need accuracy. I need you to follow a plan. But now we've talked many times about the tools that are going to come alongside human beings in real time, both on the back end as you design and in the factory that's putting this together, but in the field. Like it is going to be this cyborg approach. So how do you find people like that, or just find regular old people and you bring them in and you train them up to go be able to do not just what we're talking about today, but evolve for what we need them to do in the future?
Yeah, it's a great question, and I certainly don't have a silver bullet or the answer because I'd probably be making millions elsewhere. But I think we're on the right path. Just really the education, the next generation that's in high school, in community college is making them understand that this next generation of trades, yes, they're going to be working in trades. And I'm glad to hear that there's that perception is changing, right? People are kind of gravitating and wanting to get into the trades because they see a steady career. But really making that tie to data center infrastructure, ensuring that when kids graduate from high school, from community colleges, they understand the real world impact that data centers and AI infrastructure have, right? So as I look at these up and coming generations, they want to make an impact in the world. So make sure that they fully understand what they get to work on. Make sure that they're excited about the potential that coming into those fields. But then it's also up to companies like ourselves, certainly at AFL, as manufacturers, as operators in the space. We all have to be educators. So these skills aren't going to come magically, and we're not going to have a bench strength that we can rely on. So we have to do our own part to ensure that we continue to educate, that we continue to teach the up and coming skills that are going to be required. As I look at the merging of AI and the automated assistance, so to speak, with our human interface, I think our next generation is probably going to be better equipped than we ever will be, because ultimately they're already being raised with those concepts, certainly working with tools together. But we have to make sure that we're pivoting that interest and that skill set into actual realistic applications in this field and industry.
Do you have a community engagement team that goes out and tries to connect with groups, or do you partner with other groups to do that?
Yeah, so we're actually very active in the community engagement space. And that is not just for educating the next generation, but we have certainly a great program just to have college students spend the summer with us, kind of see how we do things, get excited about fiber, but then also just in the data center community, a lot of the fantastic groups that we're doing some really amazing, impactful things to get this next generation excited about what data centers do. And even, since I'm fortunate enough, I get to work in a company that is global and working with some of the biggest companies in the world. Just the notion, hey, you get to travel the world. You get to see, work on projects all over the world. That is a really an exciting driver for some of these younger folks that graduate high school. They want to do something that matters. They want to experience life, and what a great way. I mean, it almost sounds like a military army recruiting commercial, but go see the world. Go do some exciting things.
Right, and you may fall in love with it. I'm chuckling to myself because where I'd get in trouble is I'd start off with a slide that said, "Hey, we're making fiber sexy again," and probably the room would be like, "No, you look like the Stay Puft Marshmallow Man. I don't think you're making anything attractive." Hey, look, we've been talking for a long time. Before we go, I try to ask everybody this: if you're looking at the next, I don't know, 3 years, 5 years, 10 years, you choose your timeline. What do you think a milestone is going to be, whether in your specific world or in the broader world, that's really interesting to see we're tracking and making progress? Or, maybe worried is too strong a word, but it's the thing that might, as they say, keep you up at night. Like, we really need to. I'm hopeful for this. This I'm really excited about. This will be interesting to see when this happens, or I don't know. We need to get better at this. For all of this good talk, all these things that we need to do, this is the thing that's got my attention. I need to make sure I solve.
Yeah, so I probably have one on each spectrum, right? And one feeds into the other. As we continue to look at the evolution of AI, the infrastructure that's required to build it, obviously a lot of excitement still happening. We're still very early on in the innings of AI. We're continuing to see some fantastic innovation, I believe, over the next few years. But on the horizon, we're already seeing the potential of quantum computing. And based on what the very early signals of what we're seeing, the infrastructure required for that will be even astronomically larger than what we're seeing today. Yeah. So all of the challenges that we're facing today, access to energy, certainly the geopolitical environment, which you kind of look at all of these technologies. You can't develop those successfully in a vacuum. Well, you can, but you're not realizing the full potential. You really need a global community with standards, regulations, innovation, all coming together to support these technologies to ensure that the impact that we want to achieve out of those becomes real. So, I fear that our progress towards getting access to energy, having equitable access to these resources, not weaponizing access to these resources will be a significant impediment over the next few years.
Wow. Great cautionary words. I feel like we have the best opportunity for success if people like you and others in our community, we keep talking about the potential for how this can benefit us, human flourishing and whatever, but we need to be purposeful. We can't be accidental. Hope isn't a strategy. And as we're moving to solve our customer problems, whatever, we also have the larger community, citizen, not just data center community, citizen conversations, global citizen conversations. Let's not weaponize it. Let's just work together and apply this in an ethical, logical way to benefit human beings. And if we do that, if we capture a significant portion of the imagination of the population, I think we'll be spectacularly successful. And if we don't, it's going to be way harder and lumpier than it needs to be. So thanks for coming on and thanks for talking about that today.
Yeah, thanks. Great time talking to you today.
Love the conversation. Thank you so much for coming on. We'll have links down below to AFL and to your LinkedIn profile. If anybody has any questions, they can follow up with you. Really appreciate it today. And I look forward to our next conversation. Thanks for coming on.